Okay, so here we are. Hopefully you've watched the video which shows where we find everything for the electronics labs and the various ways to show things when you're doing your write-ups. Now I'm going to specifically look at Lab 4. So we've already, again, I'll just reiterate, you've already had a video lecture on Lab 4 prior to spring break or prior to now, and I am just showing how Lab 4 might look in Multisim. So I already created most of these circuits, discard the changes there, and let me go to our naked diode gate. Naked diode gate meaning it's got no inputs or outputs. It's no more exciting than that. So here's our diode OR gate. So this is one of the early things that you need to do in Lab 4, the diode OR gate. So how do we do this? How do we look at this in Multisim? So in Lab, we would attach a power supply here, whoops, and we'd attach a power supply here, and we'd look at the output here. In practice, how do we do this? Well, I'm just going to go ahead. I already did it. I'm not going to build it while you watch. The non-naked diode OR gate is here. So what I've done is I have attached a 5-volt power supply. You could attach two 5-volt power supplies, but I actually was a little bit more tricky. Attach a single 5-volt power supply with two switches. So that allows me to put, right now, the input to D1 is low and the input to D2 is low, but I can go ahead and close this switch. By the way, if you're not running the circuit, you can just click on the switch and click this button here to close it, open it, close it, open it. I can close the switch and that would be a 5-volt high there, right? And then to show the output, I attached an LED. Again, to ground, you got to make sure you have grounds everywhere, but I attach an LED to show the output. So I can go ahead and run this, and this is an OR gate. So right now both inputs are low, I guess, yeah, both inputs are low. Depending on whether this is TTL or some other family, if it's open, it's actually high, but it doesn't matter. Right now, it's low in the sense that there's no voltage. We're pretending it's a 0 voltage. I guess what we really should do is we should switch it between ground and 5 volts. But anyway, for the sake of this lab, this is fine. Right now, we're pretending that there's no voltage, so the two inputs are low. So I'm going to close this input. It's an OR gate. So what's going to happen when I close this input? The LED turns on because it's one or the other, right? Open this input, the LED turns off. Close this input, the LED turns on. Open this input, the LED turns off. Close this input, LED is still on because it's one or the other or both. It's not a NOR gate. A NOR gate is, I'm sorry, not NOR, exclusive OR. Exclusive OR would be only one or the other, not both, but this is an OR gate. Okay, so there you go. That's how to, in practice, do your diode gates. Now we could, because I brought it up in the intro to Multisim, we could instead make this a digital gate. I'm going to go ahead and open up the other one. Instead of doing analog inputs, right, 5 volts and looking at an LED, I'm going to do digital inputs. Go to my circuits, discard those changes. Here we go. Over here, this is the diode OR gate with a digital pulsar and probe. Okay, so instead of a 5-volt power supply here and an LED here, what I've done is I've just attached those digital pulses and looking at a digital probe. So I can go ahead and run this, and both inputs are low, so the output is low. I can turn this input high, the output is high. Turn this input low, the output is low. Turn this input high, the output is high. I turn both inputs high, the output is still high because it's a regular OR gate. So that's the way to do it digitally, right, with a digital pulsar and probe. So again, in the lab, I talk about either using power supplies and an LED or using a digital pulsar and a probe. And this is the other way. So I've actually done everything you need to know in order to complete Lab 4 in Multisim. You're going to complete Lab 4 in Multisim and do your write-up by next Wednesday lab time. By then, I will have a lecture for Lab 5, and expect you to do Lab 5 in the following week. Lab 5 is a short lab. It's a 1-week lab. Unless I change anything because of the schedule changes. For now, I think it's a 1-week lab. Okay, sorry, my mistake. I just paused the video and went and looked. It's a 2-week lab. That might change to a 1-week lab, but I could probably keep it at a 2-week lab. Lab 5. And I will ask you to write up Lab 5. I know that some of you had hoped to do extra credit in order to not write up Lab 5, but I will ask you to write up Lab 5 since we can no longer do the Science Festival. We're all disappointed that the Science Festival has been canceled and that all events have been canceled for the rest of the semester. Okay, the one last piece of Lab 4 is the multiplexer. So the issue in Multisim with the multiplexer is you need the paid student version in order to do the multiplexer. So there's 2 solutions to that. One is that I believe for Lab 5, I might ask you to install the paid student version or the demo, the 30-day demo, so that you can access more of the chips. I'm going to see if there's a way around that and to do the free version, but I might end up asking you to install the professional version or whatever it's called, and so that you can access more chips. There is no multiplexer in Multisim Live Free. So the last part of the lab for Lab 4 does require a multiplexer. So you can either download the premium version and install it and get a multiplexer, or here's the other option. I have found somebody who created a multiplexer in Multisim Live Free. So rather than having a single chip, which is the whole idea behind digital circuits, is that you find something cool and you put it on a single chip, somebody created a multiplexer out of Diode, out of individual logic gates. So let me go to, and I stole it. Let me go to the multiplexer. Here's the multiplexer. Okay. So the multiplexer, when you read the lab, I see what I'm trying to do is I'm trying to ask you to look at the multiplexer and see if you can figure out what's going on. The idea of a multiplexer is that you put in a digital address, an address meaning just a number, 0, 1, 2, 3, 4. And what that tells the multiplexer, okay, so these are the inputs, 1, 2, 3, 4. These are the inputs and this is the output. Okay, but this here is the multiplexer. Okay, so I could go ahead and delete the inputs and somebody built a multiplexer. This is a 4-input multiplexer rather than an 8-input multiplexer. That's okay. In the lab, I talk about an 8-input multiplexer. If you're going to use the 4-input multiplexer, then go ahead and use the 4-input multiplexer instead of the 8, and don't worry about the lab talking about 8. But I want you to look at the way it works. So the idea behind the multiplexer is that there are 4 inputs, A, B, C, and D, or 8 if it's an 8-input multiplexer. And there's an address. This is the address. And what the address does, it tells the output which input to read. So right now the address is 0. So the output is going to read the input at 0. Sorry, let me say that again. Yeah, so what I didn't explain is that we would call this this the 0th input, this the first input, this the second input, and this the third input. And we don't want to do any logical function on these 4. Okay, so the multiplexer is not a logical function in that sense. We just want the output to be one of these 4 inputs, right? So let's say that we just want to sequentially read, what does this say? What does this say? What does this say? What does this say? Right? And so we could sequentially number through them, count through them, 0, 1, 2, 3, 0, 1, 2, 3. This is actually a really useful function in many ways. I believe I talked about it in the video for this lab. But anyway, so right now it's address, this is the address, and it's addressed 0. So that's going to be the 0 input. So let me go ahead and turn this on. The address is 0. Notice the output is low because the input is low. Turn the input high. Oh, the output's high. Okay. So because it's just reading this is the address, and the address is 0, and so 0 is the 0th input. Let me turn that off and turn this on. What happens if I turn on input number 1? Nothing at all. What happens if I turn on input number 2? Nothing at all. What happens if I turn on input number 3? Nothing at all. Because it's only reading what's on address 0 on the 0th input. Let's go ahead and change this. This is presumably the 1's place, and this is the 2's place. So let me make that a 1. So now it's going to read what's on the 1 input, right? So that's this one, the 1 input. Okay, so turn this on, nothing happens. But turn this on, and the output goes high. Turn this on, nothing happens. And turn this on, nothing happens. Okay? Turn that off, turn this on, right? That's 2, right? Digital 2. This is the 1's place, this is the 2's place. Or 3, right? 2 plus 1 is 3. So right now, that was already on. 0, 1, 2, 3. It's taking the input from 3 and making it high. So let me turn these all off and just show. Okay, turn that on. Okay, if I want that one to be the one that shows, that's 0, 1, 2, so that should be just turning this on. 2, there you go. Turn this on, does nothing. Okay, address number 2. Okay, anyway, so that's the multiplexer. What I'm going to do is make this circuit available to you to mess with and make sure you can understand what's going on. But what I'm going to do is I'm going to remove the inputs and the output and let you add the inputs and outputs and figure out what's going on. Okay, here's the naked multiplexer. I'm just going to show it to you rather than marking it up to show you where the inputs are. But here are our 4 inputs. 0, 1, 2, and 3. So those are the 4 inputs. They are equivalent to, in the lab, these 8 inputs here, right? So these are the inputs that we want to send to the output. We only want to send one of those inputs to the output. We address those inputs here in the multiplexer in the lab. Okay, so now let me go back to, the picture. Okay, so those are our 4 inputs. These are the addresses. I just put connectors here to show where the addresses go. These are the addresses. You put the addresses in on these 2 inputs right here. Those addresses, again, that's where we address it here, right? So we address it. We give an address of which one of these goes to the output. And then this is the output here. So what I want you to do is to take this multiplexer and put something on the inputs, put something on the addresses, put something on the outputs to show you understand how it works. And this circuit I will share with you. Okay, that's a pretty good summary of today's lab. I'll go ahead and, obviously I'm going to post the videos, but when you see these, they'll already be posted. And you should complete Lab 4 and come back next week for the pre-lab lecture for Lab 5. It'll be posted by the time Lab 5 is supposed to start next Wednesday at 1 p.m. In the meantime, of course, always feel free to contact me in any way to ask questions.